All right. 107. Number 107. What is the molecular weight? All right. Question mark. What is the molecular weight? The problem does not say density, so I'm not going to use the D, and because I'm looking for molecular weight, I'm not going to use the N. Those are two things that are not going to be used this time. All right, so what is the molecular weight? And I have 20.83 grams. And it has a volume of 4.167 liters and a pressure of 79.97 kPa, and it's at a temperature of 30.0 C plus 273 is equal to 303 K. And our R that we need is that fourth row on our table, 8.341 liter kPa mole K. Okay? That's our unit. Yes.
Where did you get that?
Off of page 384 in your book. You got yesterday? All right, so page 384 for those of you who were out yesterday. Now, which formula am I going to use? I have a formula that has a D in it, I have a formula that has M's in it, and I have a formula that has an N in it. Which one do I use? One that has the M's in it. All right, which M am I solving for? The big M. So circle it, divide both sides by PV, so capital M is equal to little m RT divided by PV. Draw you a nice long line. I'm trying not to throw it uphill next time. Okay, nice long line. Because we have a lot of stuff to put on there, a lot of letters to put on there, because units are important. We're going to write our units down, no matter how much we don't like doing it. Because I don't like doing it either. But if I do it up here, I expect you to do it on your test. So the first thing I'm going to write down is my M, because it's the first thing in my equation over here. So my M is 20.83 grams. My R, I need a top and bottom, and it's on the top, so 8.341 liter kPa mole K. And my T is going to be 303 K. And my B is going to go on the bottom. My P is going to go on the bottom. I'll put it right here, 79.97 kPa. And my B also goes on the bottom, 4.167 liters. Remember, those of you who were absent yesterday, our unit of volume always has to be liter. If it's given in milliliters, I've got to swap it. I've got to go ahead and convert it right then. Otherwise, my units won't cancel. So we're going to make sure our units cancel. So we're going to say, what happens to the G? Where? Doesn't cancel. What happens to the L? It cancels. The kPa? It cancels. The mole? No, it doesn't cancel. My K cancels. So I am left with grams. Let me erase this again. Make my line longer than I need it, but that's okay. I'd rather have it too long than not long enough. All right, so I have gram per mole left. And what unit does the capital M have? Gram per mole. Because I have a mole down here, and I have my gram up here. Now, somebody calculate that and tell me what the answer is. 58.0. So I don't know what gas that is. It's awful high to even be a gas. But they said it was a gas, and that was the problem. Suppose I had done all this work, and I plugged in all my numbers, and I came out with an answer of 28 grams per mole. What gas might that be? What gas might that be? Look at your periodic table. There's not many gases on that periodic table. So let's look at them systematically. N. Can it be N? Yes, because N is diatomic. So 14 times 2 is 28. So it's probably N. Is there one of the noble gases that's about 40? About 28? So that's our best guess. So if I ask you, what is the gas? You would say nitrogen. N2. Not O2. O2 32. It's not chlorine because it's 71. Because it's double. In order to be a free gas, it has to be double. Okay, so my best guess on that one would be nitrogen. All right, what's 119? 119. An unknown gas has a density of 0.405 grams per liter. Now that has to be in liters. That unit has to be in liters. If it's grams per milliliter, I have to change it to liters. That has to be liters. Now I have a capital M in that formula, but I don't have a little m, and I don't have an n. So the formula that has D does not have a big little m or a little n. So we want to take those out. We got density. It says the word density. And so if it says density, I'm going to need to use the formula that has density in it. All right, so we have a pressure of 8.889 atm. Is there a V in that formula? So I don't need a V. There's a temperature of 7 plus 273 equals 280 K. And there is an R, and the R should be the ATM, so 0.0821 liter ATM mole K. All right. So I'm looking for the capital M. So I'm going to circle what I'm looking for. And I'm going to divide both sides by P. The P on the left cancels. So my equation is capital M. Oops, I didn't do a very good job making it capital. Capital M is equal to dRT divided by P. Nice long line to substitute on. My density, it's a fraction, so I need a top and a bottom. So 0.405 grams per liter. My R is a fraction, so I need top and bottom. And since the R is on the top, the number goes on the top. Okay. My T is 280. And my P is 0.889 atm. Now, just for a check, this is the density, this is the R, this is the temp, and this is the pressure. So does that match what I have up here? Yes, I have dRT across the top, and on the bottom I have pressure. And so I should have a number a number. I should have a number, a number, a number, and a number on the bottom that came from those values. All right, calculate. Somebody will just give me an answer. Should have 3 significant figures.
10.5.
All right, so 10.5. What's the unit? Let's cancel them. What happens to the G? Nothing. What happens to the L? It cancels. The ATM cancels. The K cancels. And I'm left with grams per mole. And we know that the unit of M is grams per mole.